Good morning, everyone, and welcome back to another episode of Solidity Fridays brought to you by Linum Labs.
What's up?
I'm joined by Gareth Larken today, and we're going to do Uniswap V3 Part 2.
Yeah.
I think it's the first Part 2 we're actually doing. We always talk about doing Part 2s, but yeah, we're finally doing it. I think the first one was in July, so it's a while later.
Yeah, there's so much to go through in this repo though, so we could
Yeah,
probably do a part three.
Part 3, Part 4. I thought it could be fun to look at their interface a bit. I'm on their info page. Um, so yeah, their total value locked is $12 billion.
Yeah,
That's crazy.
that's
Um,
mad, dude.
and this is their volume over 24 hours is also crazy, 1.14 billion.
And
Um,
USD is their highest coin. Okay, that makes
it,
sense though.
that does make sense. Followed by
Yeah.
DAI and Ether makes sense. Wrap Bitcoin, Tether, yeah, to be expected. But then Frax is the
Stable
first,
coins are taking over.
yeah, and Ethereum following shortly behind. And then also Frax is the highest um, DeFi coin. So that's cool. Go Frax.
It's actually an interesting question if you look at this. I saw someone on Twitter post the other day, are stable coins the future of currencies? And like if you're watching them on like their liquidity and marketplaces, etc., does seem like it's going that way.
Yeah, that's very interesting. Please send me that tweet, actually.
Will do. I'll retweet it.
Okay, rad. Um, I don't know what ad shares is.
No, me neither. I'm actually gonna look that up.
I wonder what happened on the 7th of March. Here, there's this crazy spike where it was 254 billion. Um,
AdShares is the first future-proof, scalable, metaverse-ready advertising exchange protocol.
Interesting.
Hectic.
It gives me basic attention token vibes, like the Brave browser
Yeah,
ad
what does
awards.
say?
Fun fact about the March 7th, aside from this spike in total value locked on Uniswap, was also the day I started at Linum.
Hectic.
So Uniswap must have known something cool was happening.
Oh, that's such a. I wonder what happened there.
Yeah, I'll look into it.
Pump and dump.
Yeah, sure. Yeah, cool. So um, this is the interface, and it obviously defaults to ETH. Because yeah, in version 1 you could only have pools and swaps with ETH, and then so if I wanted to swap USDC for DAI, I'd have to do 2 pool interactions. But now you can choose any of these many coins. So cool to see how it's grown.
Yeah, it's so much easier. It saves so much gas as well.
Yeah, absolutely. And yeah, and then V2 you didn't need ETH, and that's when it became the most popular app on Ethereum and one of the most forked projects. And I think they got annoyed with the forks, so the V3 has a different license now, so you can't actually fork it
Ah,
until a certain time lapses, by which time they'll probably be on V4. I wonder what V4 will entail.
hmm.
Yeah, and then V3 brought about concentrated liquidity and also non-fungible liquidity, which we can look at now later in the proof of free. We'll look at some of the non-fungible token position managers.
Yeah.
Cool. So, and then you can make a pool and vote and stuff. Yeah.
It's quite sleek. I like the
Yeah, it
face.
is nice. It's got a nice gradient that's kind of ruined by my dark
Yeah.
mode. Sorry, Uniswap. Cool. So, without further ado, let's get into some code. Ooh, this is bright. I hope the dark mode's okay. We usually do it with light mode, but it hurts my eyes.
Yeah, it looks fun.
Cool. So on our part 1, we covered the V3 factory, a bit of iQuota and iFactory. Yeah. So we have quite a bit that we can still look at. If there's time, I'd love to dig into the tests because they're written in Solidity, and I always love reading tests in Solidity. Yeah, it makes me really happy that it's not in JavaScript or TypeScript.
Yeah, it's actually once you get used to writing a test in Solidity, it becomes a lot quicker to write tests.
Becomes so fast.
Yeah, just because it's all kind of by habit by now.
Yeah, there's not that context switch. Um,
Cool, let's jump in.
yeah, all right. I'm just going to change from the main branch to the 0.8 branch.
Yeah.
Which is just a nice update they did in May. But it doesn't matter if you're using Foundry or Hardhat to have incompatible versions. One of our viewers, I'm going to say his name wrong, I'm so sorry, Francois Guyot, he commented on the last one saying that if you use the Foundry cheat code, deploy code, you can deploy non-compatible versions of contracts. So that's a nice tip, but I just like to use the 0.8 anyway.
Hectic, I didn't even know that.
Yeah, fun fact.
Fun fact.
We touched a bit also on the no delegate call,
Okay.
which was just a security thing they did. So where should we start? We didn't look at the pool deployer, I don't think. So maybe we dig in there, and then we can look at the pool, and then in the periphery, there's a whole bunch of stuff we can look at. There's these 4 contracts and also so many libraries.
Cool. Let's jump in. Let's start with the pool deployer.
Okay, awesome. Am I zoomed in enough?
Yeah, that's all good.
Okay, cool. So yeah, when I was talking about the license, it's this Bustle 1.1. It's like a proprietary license, but only for a time limit, which is quite cool.
Okay. Can you set that time limit?
Yeah, it's set in the Bustle. No, I think this is their own license that they made.
Okay.
Cool. So it imports the pool. I'm wondering if we should start with the pool itself or the deployer.
Let's go to the pool because
It
it's
imports it, yeah.
importing it, yeah. So let's make sure we understand that first.
Cool.
Sweet.
Cool. It imports a lot of stuff.
Okay, definitely not going to go into all of those.
Yeah, but let's just see. It's yeah. I'd love to go into the Oracle library and the position library. Oh, and the tick library was most things use the tick library. Yeah, and then it imports a few contracts as well.
Yeah, it just seems like it's mostly math things and then just some other stuff that they need to call in their repo.
Yeah, right. Cool. So it is a Uniswap V3 pool. I don't think we need to look at the interface because
No.
it'll be pretty bare. And no delegate call, which is that security thing that they added. Cool. Yeah, this is just implementing those math libraries. Okay, cool. Then they have some immutable addresses and a UN24 fee.
Yeah, so that token 0 and token 1 are the 2 tokens that are going to be used in the liquidity pool, obviously. And then the factory is just, I would assume, the factory address.
Yeah, I would assume so too.
Yeah. And the fee is one of, if I'm not mistaken, there's 3 fees, right?
Yes, I was about to say that. There's 3 set fee values. That's correct. And then the default one is 3%, I think.
Yeah.
So it's
0.03.
Which they make 3,000 or 300.
Yeah.
0.03.
And what are the others? I think it's 1%, 3%. And I'm not actually sure of the other one.
Maybe we'll see it in the docs later.
Most likely.
Cool. Then there's the tick spacing and max liquidity per tick, which is, yeah, an int 24, and then the other one's a uint 128. So this must be an int 24 because it can be a negative tick spacing as well.
Yeah, I was about to say that has to obviously encounter negatives.
Cool. Then they have a storage struct. Let's dig into that. Cool. It's got the current price, which is a uint 160, the square root price x96. Deriving that value is such an interesting thing to do.
Yeah, the maths.
Yeah, gosh, lost a few hours to that one day. The current tick, then observation index, which is the most recently updated index from the observations array. I think that might be for when you're getting the price in, if you don't go from the current price, if you go from the observation price instead. So you can get like a price over a time period, but I'm not too sure.
Yeah, I'm also wondering because if you go up to the top when they instantiated the oracle, it's also oracle.observation on line 35.
Mm.
So I'm just
Okay, yeah, we
very
must definitely check out the Oracle library. It's a really interesting one.
yeah.
Nice. I didn't notice that. Good catch. Then they have observation cardinality, which is the current maximum number of observations that are being stored, which they have here, I think, is this.
So the observations are basically, um, if I'm not mistaken, when a user wants to get a specific time, they can send in the TWAP, which is like the time weighted
Yes, the
average they want
time-weighted
to
average
go,
price.
and how many seconds back they want to go, um, and then you receive observations. So there's a function we'll see in the observation library, I think it is, or somewhere there where there's an observe function, and it sends back observations from that specific time period. Um, I don't know. We'll have to see, but I think that's where it's going.
Okay, yeah, that's cool. Then they have another UN16 observation cardinality next. This is the maximum number of observations to store triggered in observations.write, which we'll see later, I'm sure. And then fee protocol, which is UNT8. The current protocol fee as a percentage of the swap fee taken on withdrawal, represented as an integer denominator 1 over X percent, where X is probably the total swap fee.
Yeah.
Okay. And then a bool, whether it's locked or unlocked,
Sweet.
which we'll probably set to true to begin with, but let's see. Cool. Then they create an instance of slot 0. Then they have these two fee growth globals. Do you know what that is, Gareth?
I don't, but I'm trying to figure it out as we go.
Let's see. Maybe it'll make more sense when we see where it's implemented. Okay, and then here's the protocol fees. It's a struct, which will probably use this fee protocol in line 65. So there's the uint 128 of token 0 and of token 1, which, yeah, just calculates the accumulated protocol fees in their units.
Mm.
And then they instantiate that. They have a uint 128 of liquidity, and then some mappings. Tick, but mat. This position probably also has to do with observations. And then they say Oracle observation, which they, over here on line 35, I think it was. Yeah, using Oracle for Oracle. So they use the Oracle library, and then they instantiate that as observations. Cool. Now they have a lock. This is to see if it's, this is to lock the pool. So that sets that pool value that we saw earlier.
Yeah.
And it's a mutually exclusive reentrancy protection into the pool to and from a method. It also prevents entrance to a function before the pool is initialized. The reentrancy guard is required throughout the contract because we use balance checks to determine the payment status of interactions such as mint, swap, and flash. Okay?
Cool.
So it's a modifier.
So if if slot dot unlocked is false, no.
Yeah. Oh.
Why would then they set it to false?
Maybe they're saying if it's not set yet.
Maybe,
No,
yeah.
no, maybe.
I don't know, because that to me is slot dot unlocked. That's
Doesn't.
asking if it's false.
Yeah.
Then you revert.
Maybe you revert and keep it locked.
Yeah.
And then proceed. And then they revert with this lock
Custom error.
Custom error, which we haven't seen. I guess they put them at the bottom and not at the top.
Must be. Do you want to go to that custom error and see if they've commented on what the LDK custom error is?
Yeah, let's see. I should have just clicked on it. I didn't expect this to be so meaty.
There's a lot of functionality in this.
Yeah.
Wow.
Wow, look how big the swap is.
Crazy.
Okay, we've done.
Oh. The modifier is not in the interface, maybe.
Oh, it might be, yeah, it might be in the interface. Otherwise, in one of the inherited. Yeah, so what did it inherited? The no delegate call, which it probably isn't in, and in the interface. Should we pop to the interface and just check?
Yeah, I want to know what that function is.
Yeah, let's check it out. Oh, here we go. Uniswap V3 pool errors. Wow, there's a lot of interfaces. Oh, okay.
Okay. Okay, that didn't give us much context on that.
Yeah. Okay.
Back we go.
Cool. Cool. Another modifier, only factory owner. Fair enough. That's just a normal only owner vibe. It prevents calling a function from anyone except the address returned by Uniswap factory owner. Yeah.
Cool.
Cool. Okay, we're finally at the constructor. They have a UN24 tick spacing, and then now they call the Uniswap V3 pool deployer, which makes sense because you have to deploy your pool in the constructor. And then these are probably the parameters: the factory token 0, token 1, fee, and tick spacing.
Yeah, those were the parameters.
And then you make this tick spacing equal the inputted pool deployer tick spacing. Ooh, my cat is walking on my keyboard. Sorry about that. And then max liquidity per tick is tick.tick spacing to max liquidity per tick of the past in tick spacing. Okay,
and then okay, cool.
Yeah, we should definitely check out the tick library. That's where most of the maths happens. Cool, the functions now. Check ticks. Takes a tick lower and tick upper, private and pure. And it basically checks that, I think, basically that the ticks are valid, that it's not.
Yeah.
Yeah.
Yeah, we just need to make sure that we aren't below the min tick and the max tick, and
also that tick lower is
bigger than the.
No, smaller than
the upper one. Yeah.
Yeah, exactly. Interesting that they did this. Oh, why they did this is because they wanted to truncate the block timestamp to 32 bits. But this method gets overridden in tests. That's interesting. So instead of just doing block.timestamp, they have this internal function to.
I wonder why they do that.
Truncation is desired, Gareth. No, I don't know why. Probably just to save on space.
That's funny. Cool.
Okay, balance 0. Private view returns the
So it's just
256.
the balance of token 0.
Yeah.
Cool.
Same for token 1, except no, exactly the same code for.
It's literally exactly the same. The
Yeah.
only difference is they calling static call on token 1, not token 0.
Yeah. Cool. Okay, function snapshot cumulative inside. Okay, I think this is just to get some tick information.
Yeah, because you're sending in your lower tick and your upper tick. Return your cumulative inside seconds per liquidity. Yeah, I think this is just receiving tick information.
Maybe after we've looked at the tick, if we
If
have
we have time,
we can come back here. Yeah.
I want to get into the meat of this actual contract.
Cool. So let's look at the observe function then.
Yeah, this will be interesting. So send in seconds ago. So how long back you want to go?
Interesting that it's a UN32 array.
Yeah, and then I think you receive certain amount of observations based on
I
how
see
many
each of those seconds.
Yeah, each of those seconds. So you can receive multiple different observations at once.
Okay, cool. And then it builds another array to return.
Yeah, returns your tick and your seconds per liquidity cumulative. Okay, cool.
And then this uses the observations.observe function, which we will see, I think, it'll probably be in the Oracle library.
It is in the Oracle library.
Okay, cool. Yeah, I really want to check that out next, maybe.
Yeah, I think we can do that because I think it's quite cool to see how they actually fetch the data. Yeah, so that's just getting your observations.
Cool. Then earlier we had the observation cardinality next, which is the max number of cardinalities we're going to observe. I mean, max number of observations we're going to observe in the future. So this just is to increase that. And it's locked with that reentrancy lock modifier.
Okay, cool. So we just get the old address probably for an event, I would assume. Yeah, there we go. It's being emitted in the event. So we get the old value.
Yeah, by calling observations. Yeah.
By calling observation cardinality next on that slot 0.
And then we call observation.grow.
Grow. Okay.
Which must be in that Oracle library.
Yeah, so it's just obviously increasing it. And then you set the observational cardinality. Yo, that is a tongue twister of note. Observational. No, it's not even no. Observation cardinality next to the new one. Yeah, and then you just emit an event. Cool.
Right.
It's just a simple setter.
Cool. Now we do an initialize function. That's exciting.
Yay.
Takes in your current price.
What does it initialize? It's slot 0 equals unlocked equals true. There in the comments it initializes unlock.
I see.
That's dope.
And it makes sense that we're starting with a price of 0.
Yeah, because we need to start with 0. If not, we revert. I still want to have this discussion on custom errors versus requires.
Yeah, maybe we have a debate episode.
I feel like we need to have a debate episode on what is actually the correct way to go when it comes to.
I think it's like a personal preference, really.
Yeah.
Always going to be, but I think both are always going to be around. But I prefer requires, but apparently custom errors are actually cheaper.
Well, I mean, then you've answered the question.
I have.
I guess it's custom errors. Cool. So we're getting the tick based on the price.
Yeah.
And then.
Interesting though, because we know the price is going to be 0.
Yeah.
So surely we could just work that out and put that in instead of doing a whole function call. But anyway. Cool. Then we initialize observations, calling that UN32 truncated block timestamp.
Yeah, and we get the cardinality and cardinality next back. And then we use
awesome.
that for our initializing our slot.
Yes.
And setting the unlock to true.
Yes. Awesome. And then we emit an initialized event. with the current price and the tick.
Dope.
Cool. That's a nice initialize function.
Nice and clean.
Cool. Another struct. Modify position params.
But I wonder why, like, structure-wise, they didn't put the structs
all together.
Yeah.
Maybe just because it's such a big contract that they want to have, like, the struct gets used maybe right below it.
Yeah.
Because it says modify position params, and then here it says some changes to a position. So maybe they're just keeping related functionality close together. Maybe. But I usually do all my like structs together and then all my functions together.
That's actually an interesting question. Like, has anyone come up with like a format or standard of how a smart contract must get laid out? Like, obviously there's all the standard things, but like, is there actually a correct way to like go, for example, variables, mappings, events, structs, enums, or like, is it kind of based on your contract itself?
Yeah, I think it's contract specific and also person specific. Like, I've read many guides on how to set up a contract like structure, and they all differ. And they're all like, this is exactly how you should do it. But I think it should depend on the contract.
For sure. Like, this makes sense since it's such a big contract to have the structs actually closer to where they're being implemented.
Yeah, I like this. Cool. So this struct modify position parameters has an address that owns the position, the lower and upper tick, and any change in liquidity, which is a int 1 to 8, and int not a uint because it can have a negative value.
So it's interesting the way that they're using like not 256 all the time. They're using like 24, 36 and stuff, which means if you go through this contract properly and you go look at the struct packing, you probably find they've put quite a lot of emphasis onto the struct packing, because so what can happen is if you have obviously you in 24s and 36 and stuff, if you don't pack them properly, you can waste a lot of storage space.
Yeah, and they definitely wouldn't have done that.
Exactly. So I'm probably in my own time just going to actually go through and check that and be like, ooh, you're wasting space here. See if I can catch them out.
I don't know if you can. Yeah, Uniswap V3s. Some genius code, I think.
No, for sure.
And it's also been heavily audited. A cool part 3 would actually be to read or like do a report on the audit report.
But it hasn't been audited by me yet.
Yes, that's true. The best auditor of all.
Exactly. So I'm going to have to come and look at it. Cool. Modify position.
Okay, so it just says effect some changes to a position, the params of the position details, and the change to the position's liquidity to affect, and it returns the position info and amount 1, which is amount 0, which is the amount of token 0 owed to the pool. Negative if the pool should pay the recipient, and the same thing for token 1. Cool. Check ticks. That I think is kind of earlier where we saw that it has to be within the min and max range, and also that lower must be less than upper.
It's exactly that, yeah.
Cool. Then they load with an S load slot 0 into memory. Then they update the position parameters. Update position we'll probably see is an internal function lower down. Okay, and then if there is a change in liquidity, then there's 2 if statements. If slot 0's tick is lower than the params of the position tick lower, then the current tick is below the past range and liquidity can only become in range by crossing from left to right. Then we'll need more of token 0. So that means it's become more valuable. So the user must provide it to the pool.
That makes sense, actually. So we need to go from left to right. So basically, we need to increase the slot 0.tick to become higher than the tick lower. So you probably find there we've got slot.tick smaller than tick upper, and then there's probably another else if it's bigger than tick upper, and then you would have to go from right to left because token 1 becomes more valuable if you scroll down a bit.
So else here it's above the current tick is above the past range. You're correct.
Yeah. Okay, cool.
Yeah, okay, cool. So then they just change that tick. And then this will probably return, well, we'll see later, but this would return, in this case, a positive value because the user must provide it, and a negative value is when the pool actually owes the user tokens.
Yeah.
Cool. So if slot 0.tick is less than params.tick upper, current tick is inside the past range. So this is kind of what you want.
Yes.
Liquidity before equals liquidity, and they do it through an S load. Then they write an oracle entry using observations.write. Amount 0, they get the amount 0 delta using tick math get square root ratio tick, and the current price of in slot 0.
Hectic.
In this instance of slot 0, which they instantiated up there. Same for amount 1, which will be probably the amount change for token 1. Cool. And then the liquidity, then they calculate the liquidity delta.
Yeah, that's quite a lot of hectic tick math.
Yeah. Okay, cool. So so yeah, then they calculate the liquidity here. Otherwise, this is the case you said. So now it's above tick upper. The current tick is above the past range. Liquidity can only become in range by crossing from right to left. We'll need more token 1, so the user must provide it. So here you don't need, in this middle case, you don't need more of either.
No, that's where you want to be.
Yeah. Okay, cool. That was quite a meaty function. Update position. Gets and updates a position with the given liquidity delta. Don't think it's going to be... Okay, cool.
I think, yeah, this is one that was called in the previous.
So it takes in an owner, tick lower, tick upper, liquidity delta, and a tick. Returns position in position, stored in storage. Interesting that they use storage there.
Yeah.
Cool. They first get the positions.
Well, they're storing it in storage. Maybe they have to update it with something.
Yeah, they must use it later. I don't think they would accidentally store something in storage that can be stored in memory.
Definitely wouldn't do that.
Cool. Then these two bools. Oh wait, so there's two fee growth globals, which they S-load. These two bools are, I think, saying if you cross from right to left or if you flipped lower or flipped upper.
Free growth. Yeah, okay, I'm happy with that. I think that's cool.
So yeah, if we do flipped lower, then it goes ticks update on line 408, but we'll get there. So if there is a change in liquidity, then they get the time using that truncated 32-bit block timestamp. Then they do a single observation. So that's observation at a specific time, not over a time range with these parameters.
Yeah.
Flip lower, ticks.update with these parameters at a specific time, and they set it to false. Flipped upper, they update the ticks, and they set this bool value to true. If flipped lower, which it won't be right now, flip tick lower, tick spacing using the tick bit math.
I wonder what flip tick does.
Yeah.
I assume I'll see it just now.
Yeah, hopefully we get there. And then, yeah, I flipped upper, flip tick with tick upper as your input.
Cool.
Then they get the fee growth inside, which is another ticks function. And then they call position.update with the new liquidity delta and these derived fee growth inside and for 1 and 0 both tokens. Then we clear any data that's no longer needed, and that's that function to update a position.
Nice. Yeah, I think it's good that we kind of going through them quickly because I really want to get to this mint and swap and kind of where the meaty stuff happens.
Yeah, the actual functionality. So it's quite interesting here. They say no delegate call is applied indirectly via the modify position here.
Okay.
Cool.
So and then just taking a recipient, lower and upper ticks, the amount, and then obviously any call data, and then obviously lock.
Yeah, you don't want to have a re-entry and C on your mint.
No, that wouldn't work very well. And return the amount 0 and amount 1. And then so now they have a
interesting. Here they use a require.
With no error message. Let's just also say that.
Yeah.
So I'd be interesting to see how they tested this stuff. Like,
maybe the first test we should look at is the pool.
Yeah, I'd like to look at that. Maybe after this we can look at that.
It would be nice to look at
V3 or something.
The pool. I mean, at a test.
But yeah, they're checking that amount is bigger than 0 because obviously it's not going to work if it's equal to 0 or below. Okay, well it can't be below because it's
I was about to say.
Sweet. Then call modify position with the recipient and your lower and upper ticks and your delta, and return your amount 1s and 2s, and I'm sure they're going to use that just now. Oh yeah, they do. Amount 0 equals the received amount from the modify parameters, I think it was, and amount 1. Interesting. And they getting balance before. If amount 0 is bigger than 0, balance before equals balance 0.
Remember, we saw that function earlier where it just takes it's just basically the balance. If not 0, get the balance.
Yes. Okay.
So
Forgot about that one.
4, 8, 6, and 7 are. And then I guess 488 is now where we do the mint. So there's a interface called Uniswap V3 mint callback.
And then the caller.
Yeah, caller is the message sender, and then an amount 0, amount 1, and data. Yeah, that will make sense. So that's where actually the mint happens, and then they check amount 0 greater than 0 and balance before.
I wonder why they have to check that again. Like, why do they constantly check that amount 0? Like, why would you check it twice? Where does amount 0 change? Do you know what I mean?
Well, now we've minted one of the tokens.
Okay, so one of them will change. No, both, I would assume.
One or both, I think.
Yeah.
Yeah. So they just check it with 2 reverts. Their revert messages aren't very, their error messages aren't very like verbose.
No, not at all.
Then they emit the mint event. Cool. Collect function takes in a recipient, tick lower, tick upper, amount 0 requested, and amount 1 requested. Okay, so is this to collect from the pool? It's kind of like a withdrawal, I would imagine.
Let's see there. Positions.get. So it gets positions for that message for that user.
Yeah,
token owed. Yeah, I think it is.
Okay, cool. So yeah, this just is a function to retrieve tokens, and it emits the event to collect. Then there's a burn function.
Yeah, I don't think we should go through that too deep. That's just
it's just a burn function. Swap cash. This is a struct. Another struct. You're solo down in a contract.
Yeah, there's 2 there. There's a swap state as well.
Okay, so now obviously we're about to get to the swap function.
Cool.
So this cache is all the parameters we'll need. I don't think we need to go through each one. And the swap state. So the remaining amount to be swapped in or out for the amount. The amount remaining to be swapped in or out of the input-output asset. So it's basically just the top level state of the swap, the results of which are recorded in storage at the end. Okay.
Cool.
There's another struct, step computations. This is all the tick maths and amounts and fee amounts and the price, square root price for the next tick. 1 or 0. Okay, cool. And now the swap function. Okay. It takes in an address recipient. Cool. A bool 041. We'll see what that is later. Amount specified, a square root price limits. That's, I think, basically a slippage amount. And then call data or any data. Cool. Yep. External. Obviously external because people are going to call the swap function. Over here. Cool. No delicate core returns amount 0 and amount 1. And it'll do the transfer somewhere probably. Yeah, it's quite a big function. Okay, cool. If amount specified is 0, okay, cool. So it must be greater than 0. Okay, then they take slot 0, that struct at the start. So we're going to update it later. If it's locked, you can't proceed. Then there's a custom error followed closely by a require.
You probably found the math is too complicated for the custom error or for some reason, I don't know.
Yeah, something like that. Okay, so this just says your price needs to be less than the. Okay, if your price is less than the start price in slot 0, and the square root price limit is greater than the min square root ratio in tick math, then yeah, then you just make sure, or if it's greater and then this is less than, then that becomes 0 for 1. And if that doesn't evaluate to message, then now it says slot 0 unlocked false. So now we are locked. We update the swap cache, getting the liquidity and that 32 block timestamp truncated function, fee protocol, seconds per liquidity cumulative x128, tick cumulative, and computed latest observation, which is false. So we'll probably compute it soon. Then there's a bool exact input. That's just if the amount specified is greater than 0. Interesting, because we checked earlier, it has to be greater than 0. So this will always be true. Oh, maybe for now. And then later they might set it to false.
Most likely.
Cool. They update the swap state and put it in memory, not storage. For now, I think. And then it says continue swapping as long as we haven't used the entire input output and haven't reached the price limit. So we have a while loop.
I'd love to know what this function costs.
Yeah, gosh. We could run it in Foundry with the Foundry just got a gas snapshot implementation in one of their later releases. So actually, we could figure it out if we run a test on it.
That's true.
Cool. Do you want to go into this in detail, or do you want to just see that we continue swapping?
Yeah, no, I think it's fine. Just the while loop, we continue swapping until those parameters are out of bounds.
And it makes sense that we have that reentrancy guard because you don't want to have an endless while loop or a while loop that gets recalled. Yeah. Cool.
You drain all the funds if you did that.
Yeah. Okay, cool. If exact input, so if the amount is greater than 0, then yeah. Interesting.
If exact input, yeah. So if it's greater than 0, then we deduct the amount in and fee amount from the amount remaining, which makes sense. And then the amount calculated, we deduct the amount out on the step. Okay. Otherwise, but I'm just trying to figure out when exact input could be false. Because like you said, we checked that it had
to. It's going to be true.
But clearly
maybe later we make it false.
Maybe.
Okay, cool. If the protocol fee is on, calculate how much is owed, decrement fee amount, and increment protocol fee. That makes sense. So that's what happens here in this if loop, if statement.
An if loop, you reckon?
Gosh, that one's going to haunt me in my sleep.
Loop.
Cool. Update global fee tracker, because remember we had that fee growth global at the very top, so we just update that unchecked. Shift tick if we reach the next price. Okay, yeah, because the tick. Okay, yeah, that makes sense. Cool. So if step has been initialized and that equates to true, then check for the placeholder value, which we replace with the actual value for the first time the swap crosses an initialized tick. Okay. If it's not, if cache computed latest, so if you haven't computed your latest observation, then you're going to observe single over here. And then you set that to true. Okay.
Yeah, that makes sense.
Then there's a liquidity net, which is ticks.cross. I don't know what ticks.cross does. So, yeah.
I will find out.
Okay.
Does anyone in chat maybe know?
Oh, you know what I think it is? I think it's similar to ticks.flip. Because it says also here, replace with the actual value the first time the swap crosses an initialized tick. Maybe. So I think it like passes a tick.
Function cross. It transitions to the next tick as needed.
Okay. Okay, cool. So this just transitions to the next tick. If we're moving leftward, we interpret liquidity net as an opposite sign, safe because it can't be typed into .min. Okay, so we just invert the sign. Okay, cool. Okay, cool. So we basically just there do some tick math and move to the next tick. Essentially, that's what all that's doing. Now we update the tick and write an oracle entry if the tick changed.
I'm really keen to see this oracle at some point.
Yeah, unfortunately, we only have 10 minutes left, so we might have to do part 3 on just the oracle library and maybe the tick library if we get time, or the oracle library and the tests.
I think we're gonna have to do that.
Cool. So this, yeah, all of this just updates the tick and writes the Oracle entry, which is here observations.write. Only if the tick changed though. So else if the tick hasn't, so this is if the tick has changed. Otherwise, we just update the price.
Yeah.
And then we update the liquidity if it changed.
So that's why that struct
was in storage. Yeah, I was just thinking that.
Yeah, we updated, yeah.
Yeah, nice, okay. Then we update the fee growth global and if necessary the protocol fees. They say here overflow is acceptable. Protocol has to withdraw before it hits type UNT 128 max fees. Okay. Okay, cool. This is just to update the fee stuff, the protocol fee and the fee growth global. All of this. Okay, now we're doing the transfers. Now we're actually doing the swaps.
Uh-huh.
Okay, interesting. So if amount 0 is negative, if amount 1 is negative, safe transfer token 1, recipient, and then you make it positive.
Yeah.
And that makes sense because if it's negative, it means the pool has to pay the user. And if it's a positive, then we transfer from the I see. So either amount 0 or amount 1 will be negative, which means that's the one that's getting swapped out. Okay. And the one that's positive is the one that's getting swapped in.
Yes.
And then you do a safe transfer of the one that's getting swapped out, either token 1 or 0, and you just by doing a negative on the amount that it is. So that's the amount that is owed. Cool. That's nice. I like that. And then there's a balance before, and then I'm sure they update the balance of oh no, it's just a check in their custom error to check that the amount updated correctly. It's a swap event. And finally, I think we're done with the swap function. Sure, that was a huge function. It's awesome. Some clever stuff happened. Cool, now we can do a flash. I just want to check how long it is. Okay, not too bad. So a flash takes in a recipient, amounts 0 and amount 1, and called data, and it returns, no, it doesn't. Just performs a flash swap, I think. Yeah, so it does some transfers here, and yeah, it just does a flash swap. I want to try maybe get to the test file for
code. Yeah, let's maybe go to the test file for this.
Okay, cool. Because all that's left is set fee protocol, collect protocol. That's it. Okay, cool.
Okay, cool.
I feel like we've done enough here.
Yeah, I want to quickly just look at that.
Yeah, we might not get through the whole thing, but let's see how much we can do test.
No, we definitely won't. But I'll be keen to kind of see how they test these errors. And
stuff. They test just the pool swap here, I think. Cool. So it imports the pool. Has two variables at the top, amount 0 delta and amount 1 delta, the change. Function get swap result takes an address pool, that pool, the amount specified, and the square root price limits 96. That's basically a slippage. External, and it returns the change in amount in the amount of token 0 and 1, and the next square root ratio.
Okay.
Cool. So it gets those two deltas by calling our Uniswap V3 pool on the pool address that we inputted, called swap. Cool.
Kitty.
Yeah. He wants more attention than I'm willing to give him right now. Oh, we compromised. He's just going to sit on my lap. Cool.
Okay.
Cool. Then the next square root ratio, it reads from slot 0. So that's also why maybe we put it in storage, Gareth.
Okay.
And then this is the swap callback, which I don't think we actually looked at. It's from this interface. It's a swap callback.
Yeah.
So that could be a thing to look at another time, I guess. Yeah, and then we won't have time to go into it. So nice seeing test and Solidity. But the pools are deployed by the pool deployer, and it calls the deploy function. Actually, maybe we do have time to quickly look at this. It calls the deploy function in the constructor of the pool.
Yeah. Yeah, that I think.
So it takes in a factory address, the address of token 0 and 1, the fee, and the tick spacing. Takes in the parameters, and then here's the deploy function. Deploys a pool with the given parameters by transiently setting the parameters storage slot and then clearing it after deploying the pool. Okay, we saw that.
Yeah.
And then, yeah, it takes in these params. So the factory token 0, 1, fee, tick spacing, returns an address of the pool. And then parameters takes in, yeah, just these parameters on line 28 through 32. And the pool equals address new Uniswap V3 pool. And then, interesting, it does some hashing where the salt is the keychack of the encoder token 0 address. So these two are addresses, and then the fees are UN24. And then here we see it deletes the parameters.
Sick.
We don't need them anymore. Rad. I think that's enough for today, but I would love to do a part 3. I mean, if you look at the libraries, there's so much to go into. I mean, we don't need to go into a lot of them, but the Oracle would be great. The position, swap math, square root price math I've looked at, and it's really quite interesting. And the ticks and tick bit math and tick math would be awesome. And this is just the V3 core. There's also the V3 periphery. And then in there, those libraries are also quite extensive.
No, there's maybe we should actually put out on Twitter what contracts people would like to see us go through.
Yeah, which of the libraries specifically, maybe.
Yeah, because then we can actually focus on like we did here. We focused on the pool. We can see what other people want us to focus on.
Yeah, let's put out a poll on, or like a poll on Twitter, and
yeah, Mick on the Twitch stream says he'd be keen to look, or he or she would be keen to look into the tick library for sure.
Okay, yeah, that's some interesting.
I think that'll be really cool to go through.
Yeah, absolutely. And then I'd also love to do a summary of the findings of the different audits that happened. Like, what did they miss, and what did they have to remedy?
Yeah, that's actually also true.
Cool. Thanks, Gareth, and thanks everyone for watching. See you next week.
Cool. Cheers, Tam. Cheers, everyone.
Bye.